Okay, so this is going to be a tutorial for how to do Bohr models. So pretty much Bohr models are just a way of representing different atoms, different elements, and how their atoms look. So the whole beginning step of Bohr models is figuring out how many protons, neutrons, and electrons are in that element and its atoms. So the way we do that is referred to as 8-man. A stands for atomic number, which can be found on the periodic table. P stands for protons, which is exactly the same as the atomic number. E stands for electrons, again, same as number of protons. So all three of these numbers are the same. Mass, which is from the periodic table. Atomic number, which is the same as this. And last but not least is number of neutrons, which is mass minus atomic number gives us number of neutrons. Or another way of thinking about it is mass minus number of protons is the number of neutrons, because neutrons plus protons equals the mass. So atomic number is equal to protons and is equal to electrons. The mass is equal to protons plus neutrons. So right off the bat, we have a lot of information. This should be pretty straightforward as we begin to do our Bohr model example. So I'm going to do a fairly easy example. I'm going to do oxygen. Symbol is O. So oxygen, if you look on the periodic table, which I'll show you in just a moment. So oxygen has an atomic number of 8 and an atomic mass of 15.999. We're going to round that up to 16 to the nearest whole number. So atomic number we said was 8. So it automatically has 8 protons and 8 electrons in its atoms. Its mass was 16 because we rounded it. Atomic number was 8. We subtract those to get the number of neutrons, which is 8. So here we have our neutrons, our electrons, and our protons. First step to drawing a Bohr model then is draw the nucleus, which is just a circle, the center of the atom. Inside the nucleus we have protons. We label those as P+, and there are 8 of those. And then we have neutrons and 0. We have 8 of those. And then we need 8 electrons. So we begin to draw our electron orbitals. The first orbital can hold a maximum of 1, 2 electrons. Well, we need 8 electrons. So we need another orbital. So the second orbital can hold a maximum of 8 electrons. We need 1, 2. We already have 2, so we need 6 more to equal 8. 3, 4, 5, 6, 7, 8 electrons total. That's all there is to it. That's a Bohr model for oxygen. Just as a little reminder for electron shell capacity, the first shell can hold 2 electrons. The second shell can hold 8 electrons. The third shell can hold 8 electrons. And I could go farther than that, but that's enough for 8th grade anyways. So each shell has a capacity. The main thing is just making sure that you've got protons and neutrons in the nucleus. You've got electrons in the outer shells, making sure you have the correct numbers for each. I hope that this tutorial was helpful for you. My recommendation would be to finish the Bohr models on page 41 if you have not already. If you have already finished that, you can practice this on your own just by looking at your periodic table and drawing different Bohr models. So you could do a Bohr model for like hydrogen, you could do one for helium, you could do one for lithium, you could do one for, what else haven't we done? We haven't done magnesium or aluminum or phosphorus or argon. So there's lots of elements left over that you can practice this on, just on a separate sheet of paper. But by the time Tuesday rolls around and you have a quiz, please make sure that you know how to do Bohr models. That's all for today. I hope this was helpful.